Hello, today we're going to take a look at how to solve systems of equations. So the first thing we're going to do is just review how we would have solved them in, say, Algebra 1 or whenever we first learned these. So system of equations, we've got an equal number of equations and unique variables. So like here we have two equations and just x and y. So one of the ways that we can solve these is with substitution. So substitution, we want to get a variable by itself. So for example, we're going to take the second equation, subtract 4y from both sides, and then divide both sides by -1 to isolate the x. Then what we do is take this 4y plus 22, substitute it in for x in the first equation. So we have 4y plus 22 instead of the x, minus 5y equals 21. Distribute the -2. Okay. And then we combine like terms. Add 44 to both sides. Divide both sides by -13. Okay, so then what we would do to solve for x is take this y value, substitute it in to this equation, and we'd end up with our x value and our y value. We're not going to do that for now. I trust that you can do that. The other method we look at is elimination, is I believe what they're calling it now. And that's what we do where we work with multiple equations at the same time. So for example, this one, we can just add these two, or sometimes you end up multiplying one of your rows by something and then adding it to the next one. So we add these two, we end up with 5x plus 0y equals 25, and then solve for x. Then substitute that back in. If we know that x plus y equals 4, it doesn't matter which equation you use. 5 plus y equals 4 because we know x is 5, and then y is equal to -1. All right, so we have our solution set here. Or the other method that we looked at was graphing. So you'd get them both into y equals form, graph them both, see your intersection, and those coordinates would be your x and y solutions. Now, what we're going to do is look at how to solve these using matrices. And when we're using matrices, we can use one of two options. The first is by using our reduced row echelon form, and the other is by using inverse matrices and matrix equations. So the first thing we want to do for either of these is set up our matrices with just our coefficients. So we're going to do this one in reduced row form with our coefficients. So we've got our x and y coefficients as our left piece here. We have the line, and on the other side of our line is what each equation is equal to. So then what we do is just solve this like we would our other reduced row problems. So what we'll do is we can do row 1 plus row 2. So then we end up with 5, 0, 25. And then row 2 is unchanged. Then we can take 1/5 row 1. We have 1, 0, 5, and then still 1, 1, 4. To finish this out, all we do is negative row 1 plus row 2. All right, so that is this matrix in reduced row echelon form. And because our coefficients in the first column are our x coefficients and our second column are our y coefficients, we have new equations here. So our first column is our x's, so we have 1x plus 0y equals 5 for our first row. Our second row, 0x plus 1y equals negative 1, and that matches up with what we found when we solved it with elimination. Now, the other method we can use is by taking inverse matrices. So we still want to solve for x and y using our coefficients. So what we want to do is, let's say z, or some other non-x, y, I variable, is the matrix we're looking for. So then we still start with so this will be a 2x1 matrix that has our x solutions and our y solutions. So what we want to do is set our coefficients matrix to be multiplied by our variable matrix, and then it's going to be equal to a 2x1 that is just the solutions. So let's call this C for like our coefficient matrix, and D because it comes after C. So we need to find the inverse of the C, because then when we multiply both sides by C inverse, we will get this Z matrix by itself. So C inverse, first thing we need to do is find our determinant and take the reciprocal of that. So it's going to be 4 minus negative 1, so it's going to be 1/5. Then we switch the location of A and D and change the sign of B and C. So we have this, and we need to multiply C inverse by D. So leave that 1/5 out, and we'll multiply by that later. And we multiply by D. Okay, so we do row by column. So we've got 1 times 21 plus 1 times 4. So we get 25. And then negative 1 times 21 plus 4 times 4. So we've got negative 21 plus 16 is negative 5. Then when we multiply by that 1/5, we end up with 5 and negative 1. Which, if we check the other methods we found, we got x is 5, y is negative 1. X is 5, y is negative 1. X is 5, y is negative 1. So we can use inverse matrices and a matrix equation to solve for this. This also works when we have matrices or systems of equations that have more than 2 equations. For example, if we have a matrix such as 18, let's just do a slightly darker color. So I want to do this one using reduced row echelon form. The first thing we do is write out our matrix with our coefficients. So our x, y, z, draw our line, and then have our what it's equal to. When there's no value, like there's no y in this second equation, so you just do 0, and then 4 for z. Okay, and then once you have that matrix, use a calculator or one of the websites we've looked at to find the reduced row form. So once you've done that, you end up with this as our 3 by 4 matrix in reduced row echelon form. So x is equal to 2, y is equal to -5, and z is equal to 0 for the solution for this system. You could also do the same thing with inverses and setting up a matrix equation. Just I would use a calculator or other tool for that. Now, there are some problems that it would be good to review about dealing with systems with word problems, so our application. So let's take a look at 2 of these. So a bowl contained 13 red and brown M&Ms. So what you want to do first is set your variables, okay? So like R is our number of red, and then B is our number of brown. Okay. So when it says the bowl contained 13 red and brown, so red plus brown is equal to 13. There was one more red M&M than brown. So you do brown plus 1 is equal to red. And then once you have this, you can solve it whichever way you would like. If you're doing, this is one where substitution would be pretty easy because we already have R is equal to B plus 1. Or if you wanted to solve it in a matrix fashion, you would have to get it to be in the same order. So we'd subtract 1 from both sides of the second equation, subtract R from both sides. So we'd have R plus B equals 13, and then negative R plus B equals -1. So then when you set up your matrix, it's 1, 1, 13, and -1, 1, -1. Or if you were doing 2 matrices, it would be 1, 1, -1, 1, and then times z, or whatever other variable you'd like to use, is equal to 13, -1, and then solve with inverses or our reduced row form. Now, some of these other ones, if we're dealing with ticket prices, for example, we could do like A for adult, and then C for child, so the number of children's tickets and the number of adult tickets. And we want to set up one equation for the number of tickets and one equation for cost. So $5 for an adult ticket, $2 for a child's ticket, sold 785 tickets for $3,280. So what you do is 5 times A plus 2 times C is equal to 3,280, because this is our cost equation. Then we also have a number because you add the adult tickets and the child tickets together and you get 785. Then our matrix, if you want to do this in our reduced row form, or you can do it with inverses, either one. You just look at the coefficients, and then you use a calculator or website to find our reduced row form. Once you've done that, you end up with this as our solution, where there's 570 adult tickets, because our 5 and 1 are our coefficients for our A here, which we've labeled as our adult tickets, and then 215 children's tickets. So take a look at the problems that are on the assignment and the instructions for those problems. Let me know if you have any questions, and thank you for watching.